So we've learned in previous lessons that if the population standard deviation is not given or not known, we use the student t distribution. But if also you know the population standard deviation, it means that we are going to use the normal distribution. And the test statistic is given as this. The other thing we want to learn how to do today is to learn how to do bootstrap hypothesis testing. And so I have listed out the various steps we are going to use to achieve the bootstrap hypothesis testing. And so we are going to implement these steps using this same example that we did earlier on Friday. So I'll recommend that you open. So here we know that our null hypothesis was mu equals 10. The alternative was mu less than 10. So now we want to use bootstrapping to be able to perform the hypothesis testing. And when we are done with that, we would attempt chapter 18 homework question 15. So open StatCrunch and then input this data set in StatCrunch, and then we will follow the procedures. So I have already done that. Let me delete this thing here. So these are the data. So try to input them in StatCrunch. Are you guys done inputting the data? So we can proceed to perform the bootstrap hypothesis testing. So the first step is let's try to compute the sample mean of this data set here. Is that okay? So this is the original data set we have. Let's try to compute the sample mean of that. So to do that, we go to stats, summary stats, which you know how to get sample means. We hit columns. I named my data coffee. I just want the mean. So I click on the mean here and I hit compute. So the sample mean is x bar equals 9.845. Okay, that is a sample mean. So write that down. And also let's take note that we know that mu naught or the hypothesized mean was 10. So let's also take note of that. So x bar is 9.845, mu naught is 10. Is that okay? Good. So since we have taken note of that, the first step is to be able to, so now let's take all these values. So to do it, let's go to data, compute, expression, data compute expression. Is that okay? So data compute expression. Can I proceed? So I click on that and then I go to build. Click on the build. So when you click on the build, now what do we have to do here? So let's click on the name of our column, which is what? Coffee. So I click on our column, double click it, it's going to show here. Is that okay? So click on the column name, so coffee. Is that okay? Minus the sample mean. What was our sample mean? Our sample mean was 9.845 plus the mu naught, which was what? 10. Is that okay? So you do coffee minus the sample mean plus the mu naught value. And then when we do that, we click on OK. And then let's label this one. Now let's come to the column label and let's name it hypothesis testing with bootstrapping. So I just name it. You can name it any way you want to name it, but I try to name it this way. And one thing you have to realize that your expression would also show here. Is that okay? Your expressions would also show here. And then we hit compute. And so it gives us those values here. Now we want to take, now I want to perform the bootstrapping to take the sample means of this as many as we can. So to achieve that, we go to start resample statistic. Start resample statistic. Start resample statistic, and then you click on that. What column do we want to resample? We want to resample the HTW boot. So you click on that. Is that okay? And then the statistic, we come on, let's click build. So when you click on build, let's scroll down to the function, or you could type in mean. It should work. So I have here mean. So I double click that. When you double click, it shows here. Mean of what? HTW boot. Is that okay? So mean of HTW boot. And then you hit OK. You realize that it shows here now. You see mean of HTW boot. Is that okay? Now we double check. It should be bootstrap with replacement. So we are good on that. I think it automatically does that for you. The number of resamples, we always prefer 1,000. Some people do 999, which is okay too. We prefer to do 1,000. And then we try to store, let's store the resampled statistic. So let's store the resampled statistic. So all you have to do is to store this. Is that okay? And then let's do compute. So you see when we do that, we have this and it's 1,000 times. Is that okay? Now we want to compute the p-value. to compute the p-value, we want to sort this. So to do that, we go to data and then we go to sort. Now we want to sort. So let's go to data and then sort. Data, sort. You click on that one. Now you'd have to come and select the column you want to sort. Is that okay? We are interested in sorting the mean, this one here, the 1000 bootstrap samples we got. So you select on that one. Is that okay? And then you just come and do the same thing here. Select that column 2 here. And then we want to sort by ascending. What it means is that it's going to sort from lowest to highest. Is that okay? So we leave it at ascending. If you choose descending, it means it's going to sort from highest to lowest, but we want to sort from lowest to highest. Is that okay? So we choose that at this. We don't want to replace the column. Instead, we want to create a new column. Is that okay? So we could have both of them. Okay? So you just have to create a new column and then you hit compute. And then now we can compute our p-value. So this is the last step. The p-value here is a one test. So this here is a one-sided hypothesis test. So we want to count how many of this sorted value is less than the original sample mean. Remember, the original sample mean is what? 9.845. Is that okay? The original sample mean is 9.845. How many of the sorted here is less than that? So you can see from here, even the lowest here is what? 9.86. Is that okay? So it tells you none. Does that make sense? We sorted from smallest to highest. So even if the first one is not less than that, it means the rest will never be less than that. And so it means it's none. Whenever you have none, we add 1 to that. So it's going to be 0 plus 1 divided by the number of bootstrap samples, which is what? 1000. So 0 plus 1 divided by 1000, it gives us 0.001, which is very close to what we did. So that is how to get the p-value, which is very close to what we did last Friday, where we had a p-value of 0.0012. Is that okay? You can double check your notes, but with the bootstrap, we got p-value of what? 0.001. And so you can now decide. You can see from here, we are going to what? Reject the null hypothesis because the p-value is what? Small. And we'll conclude that the machine is shortchanging customers, or we have enough evidence to say that the machine is shortchanging customers. Now, let's do chapter 18. I recommend you open to chapter 18, question 15. That one, the p-value for the bootstrapping is a bit tricky. So the first class that I did to the p-value, but I showed them how to do it, but I didn't do it. But I want to show you everything, then I could upload this video instead. So let's open to chapter 18, question 15. Have you all been able to open to your chapter 18 homework, question 15? Okay. So since we all have this, let's try to solve this. I'm going to do it fully. So make sure that you understand as we go along. So the problem here says that according to mine, I think everybody's own is different or might be a slightly different. According to a government organization, a body mass index of more than 24.9 is considered overweight. The given data contains BMI of 200 men. The means from 200 bootstrap samples are also given. And then you're asked to complete parts A through D below. So how do we do that? So question 1 says that find the mean BMI of the men. So to find the mean BMI of the men, that means the mean BMI of the main sample. Is that okay? So you have to click on the first one, not the bootstrap sampled. So click on the first one here. And then when you double click on that, you have something like this. And then you can click on open in StatCruch. What are we looking for? We are looking for the mean. Is that okay? So to do that, we go to stats, summary stats, columns. I didn't name the column. You can name your column BMI, but I didn't name it. What do I want? I want the mean. So I click on this one here. Is that okay? And then I hit compute. So you see, my mean is what? 25.0775. So my mean is 25.0775. Okay, so to do that, I come and input my mean here to be 25.08 because they say I should round to 2 decimal places. Is that okay? I check that. Did everybody get the A right? Okay, let's get to B. The B says that we should find a bootstrap 95% confidence interval, okay, for the BMI of the men. So to be able to do that, what we have to do is to now, we are looking for a 95% confidence interval. I have already showed you which intervals to use in our previous lessons. So with the 95% confidence interval, we need the 2.5 percentile and then the 97.5 percentile. If you are confused on how I got that, I think you should watch the previous lesson videos, which I have uploaded on As You Learn. So now we need to open our bootstrap sample means. So let's open that because we want the confidence interval for that. So let's open that and then click on this, open in StatCruch. What we've learned how to construct the confidence interval for bootstrap samples already. But this is a bit different because what we learned, we go and resample and then choose those percentiles. But here we've been given the bootstrap sample means. So we just need the percentile. So you have to be able to know you need a 2.5 percentile and the 97.5 percentile. So to do that, let's go to stats, summary stats. Let's go to the columns and select this column here. Is that okay? Good. I don't need the mean standard deviation. I don't need anything. But here, see, it's selecting everything for you. So I just want to choose mean. Or you could choose n, anything. I don't need them. But I don't want it to show everything. I don't want anything long because I wanted something that is short. So now here is the main thing. We want to enter the 2.5 and then the 97.5. So you see, to do that, it tells if you want the 30th, you enter 30. So if you want the 2.5, we need to enter 2.5. And then we separate that with a comma, enter 97.5. Is that okay? And then I click on this one here, compute. So the 2.5 here, if it's the 2 decimal places, I have to 24.61 and then 25.50, I think. So let's try to enter that 24.61. So I have entered mine. Can we proceed? Okay. So to proceed, C says we should find the p-value of the bootstrap test for the hypothesis that the mean is, so you see we've been given a hypothesis value, that the mean is 24.9. So H now is mu equals 24.9. What do you think the alternative would be? Anybody to help us with the alternative? So the alternative would be what? Not equal to 24.9. Is that okay? And then we click on that. Okay. Now, how are we going to get the bootstrap p-value? This side is a bit tricky. So before we proceed, I want you to write down your sample mean. So for example, my sample mean, which is X bar, is 25.08. Is that okay? 25.08. What is my mu naught? My mu naught is what? 24.9. So my mu naught here is 24.9. I want you to write that down as well. Is that okay? Okay. Can we proceed? Okay. So to be able to get the bootstrap p-value, let's click on the bootstrap sample mean here. So click on the bootstrap sample mean, open in StatCruch. You see, we have something like this. Is that okay? Now let's go to data, compute, expression. Data, compute, expression. We go to data, compute, expression. I click on build. So you see the column name is var1. Okay? We subtract the sample mean. So minus 25.08. And then plus 24.9. So you see, you subtract the sample mean first, then we add the mu naught to it. You see, that is why I asked you earlier on to write your sample mean and write the value for mu naught. Is that okay? So I wrote mine down and so I implemented them here. Is that okay? And then you just click on OK. And then let's name that new column HTW boot. And then let's hit compute. So when you hit compute, we get this. These are bootstrap samples already, so we don't need to go create many resampling. So since we have this, the next step is for us to sort this. Is that okay? So now let's sort this one here. So to sort, we go to data, sort. Let's go to data, sort. So when you go to data and then sort, we have, you can click on select column. We are interested in the HTW boot. Okay. That is how I stored mine. Sort columns by HTW boot. Okay. And then I create a new column. So HTW boot, you create a new column and then you hit compute. It has sorted that for us. Is that okay? Good. Now, this is the tricky part. This is two-tailed test. Unlike the first one that we did that was one-tailed, this is two-tailed test. So to be able to get the p-value, first and foremost, my sample mean was 25.08. Is that okay? And then my mu naught was 24.9. Okay. So how did this move to become this? What I did was that it was this minus the sample mean plus the hypothesized mean. Is that okay? So it means that I added point negative 18 to all these values to get this. To get this. Is that okay? So you added point negative 18 to this to get that. Is that okay? That is how come we got these things here. You can try to check. Add, so this is 24.85 minus 0.18. It gives you 24.67. You see, it's the same thing for everything. So to be able to read the p-value, our mu naught, for example, my mu naught was 24.9. So 24.9 minus 0.18, what would I get? 24.9 minus 0.18. That gives me 24.72. So do yours. What do you get? Minus 24.72. What did I do? So I did, what was the difference here? So I do the negative of the sample mean plus that. That's how I got a 0.18. So I do 24.9 minus 0.18. I get 24.72. Sample mean, which is X bar, is 25.08. And then my mu was 24.9. How did this become this? I just did whatever is there. So minus 25.08 plus 24.9. And I get minus 0.1. So it means that this column here added negative 0.18 to get everything here. Same thing to get everything. Is that okay? So what I'm asking you to do now is step one is that take the hypothesized value, 24.9 minus this, and then 24.9 plus 0.18. I know this one is 25.08, I think. And then that one was 24.72. So I want you to do this for yours. Is that okay? This is mine. Is that okay? So do this for yours. Okay? So when you calculate, I got the hypothesized value, which is 24.9 minus 0.18. I got 24.72. And then the hypothesized value plus 0.18, I get 25.08. You need these two values to be able to calculate the p-value. Is that okay? That is why I'm asking you to calculate yours. Is that okay? Good. Any questions? So we are all good on that. Okay. So now to get the p-value, we are going to do that in two stages. Stage one, let's count all the sorted values that are less than or equal to 24.72. So for example, let's focus on this one here. We are going to count all the sorted less than or equal to 24.72. Is that okay? So you don't need to worry. So you just have to, so for example, in my case, I have to just scroll down and then I see it ends here. Do you all see that? What number is that? In my case, it's 57. So it means that there are 57 of them. Okay? Plus, the next step is we are going to count all that are greater than or equal to 25.0. So now I'm going to count all that are greater than or equal to 25.0. Okay? So to do that, now we are going to count all that are greater than or equal to even the sample mean is the same thing, which is 25.08. So to do that, you have to scroll down here. And then you see it starts from here. Mine starts from 162. Is that okay? I'm counting greater than or equal to. Is that okay? So from 162 down, they are all greater than or equal to 25.08. Is that okay? Does that make sense? Now, how do you count how many of them? When it was less than, it was easy. For the greater than, there are two ways. One way is to count now 1, 2, 3, and count till you end at 200. Or you could do what number is here? 162. Is that okay? So you do 200 minus 162 plus 1. That gives you 39. Is that okay? I added plus 1 because 162 is also part. Is that okay? So you do 200. My case is the total samples are 200. You can either count 1, 2, 3, 4, 5 till you get to 200, or in my case, it starts at 162. So 200 minus 162 plus 1, which is 39. So then I get 39 for that. The first one, what did I get? I got 57. So all you have to do is to do 57 plus 39 divided by 2. That is the p-value. So 57 plus 39. So I got 0.48 for mine. So that is correct. Is that okay? Good. That is how to compute the p-value for the two-sided. Now let's try to finish up by comparing the answers in part A and B. Now, first and foremost, is this value in the confidence interval? Yes or no? Is this value in this confidence interval? Yes. If it is yes, it means there is little evidence. If it is no, we reject. Is that okay? So this is here, it means yes. So there is what? So it means we fail to reject. So there is what? Little evidence or no evidence. Now, the hypothesis test. Is this p-value small or large? Large. If it's large, what do we do? We fail to reject, right? If you fail to reject, what does it imply? Little or no evidence, isn't it? Yeah, if it is large, we fail to reject. If you fail to reject, it means there is no or little evidence. Is that okay? So if there is no or little evidence, it means that what we fail to reject. So this is what equal to this. So you can see this is what the same. So that is it for that. So that is how to do question 15. Now let's start with chapter 19. In chapter 19, it is similar to what we did in chapter 18. It's just a build up and to help improve your understanding. We already know what the p-value is. So here we are trying to review its meaning. And then we're also going to look at the significance level. And then remember, we are doing a hypothesis testing. It means that we could make mistake. How can we make mistake? If the null hypothesis is true and you reject it, you've made a mistake, isn't it? If the null hypothesis is false and you fail to reject it, it means that you've also made a mistake. Is that okay? We are going to look at those types of mistakes and then look at the binomial distributions too. So what is the p-value? One thing you have to understand is the p-value is a conditional probability. So it tells the result of getting at least as unusual as of the observed statistic. So given that the null hypothesis is true, that is what the p-value means. So you can see I wrote that here too. So I recommend that you write this meaning in your sheets because you are going to be tested on the interpretations of that. I have a simple example to explain what the p-value mean. So for example, imagine you have a glass of juice and then someone says that, oh, this juice has exactly 10 ice of cubes. So you can see, right? This juice has exactly 10 ice of cubes. You are not sure, so you take a sample glass and then you count only 6 ice. Now you wonder if they were telling the truth, how weird it is to see just six ice cubes in your sample. Is that okay? So this question here is what the p-value tries to answer. Does that make sense? Good. And so if you get a p-value of 0.03, what it means is that given the null hypothesis, there is a 3% chance of observing the statistic value that we actually have observed. And so I went ahead to also give a short example of how to interpret a lower p-value. So for example, when you look at this example here, it says that a New England Journal of Medicine paper reported that the 7-year risk of heart attack in diabetes patients taking the drug Avandia was increased from the baseline to an estimated risk of this. And the p-value is this. So you can see when the p-value is small, they reject the null hypothesis. So it means that what they concluded that there is what an increase in risk from the baseline. Now, how would you interpret this low p-value in this context? So what in this context, it means that the probability of seeing what a high heart attack rate differs from the what expected rate among the people studied. If taking Avandia, so you see, this is the null hypothesis. If taking this Avandia didn't really change the risk at all. So that is how to interpret the null hypothesis. So the p-value, a low p-value, sorry. Now we are going to talk about alpha levels. Remember in chapter 18, I gave you one trick that we are comparing the p-value to what? 0.05. Is that okay? So this was our baseline. Is that okay? So this baseline value here is what we called the significance level or the what alpha level. Is that okay? So that baseline is what the alpha or the threshold is the alpha level. And then they use the Greek letter to denote it alpha. So anytime you see alpha, it is what the significance level. It is also the type 1 error. We'll get to that. But your exams also gives you symbols and asks you what that this symbol stands for. So you should be able to know that if you see alpha is the same as significance level, type 1 error. We'll get to the type 1 error part, but I just wanted to draw your attention to that. So this p-value, this value here is the what? The significance level. Now, why is it that in chapter 18, I was informing you to use 0.05? Now, if the alpha level is not given, we use 0.05 as the threshold. Is that okay? There are some problems that can give you the alpha level. So the common alpha levels are, you could see 0.1, 0.05, 0.01, 0.001. There is no justification as to what value they are choosing, but usually people prefer 0.05. So that is why in chapter 18, I was asking you to compare those p-values to 0.05, and using that, you're going to tell whether the p-value is low or high. Is that okay? That is what we learned. So just know that when p-value is less than alpha, what do? We reject H naught. If alpha is not specified, use 0.05. I repeat again, if the p-value is less than alpha, we reject the null hypothesis. Is that okay? If the alpha level is not specified, use 0.05. Is that okay? And then the alpha is the same as the significance level. So I want you to open to your chapter 19 homework, and let's try question 7. So open to chapter 19 homework, and let's try question 7. So open to chapter 19 homework, and let's try question 7. So I'm going to give you a minute to read this problem. When you read question 19, what I want you to tell me is, I want you to tell me, what did the researcher do? Did he reject or he failed to reject, and why? Is that okay? So read question 7, and then let's try to answer that. Anybody wants to help us? Did the researcher reject the null hypothesis, or he failed to reject the null hypothesis? And why? First and foremost, what was his conclusion? Do you want me to call your names, or you want to try? Wesley, what was his conclusion? Why? Okay, I see. So when we read this one here, we can see from here, and he concluded that a new scanner is significantly better than the current scanner. That is his conclusion. Is that okay? Do we all agree to that? So now my question to you is that, what did he do to arrive at this conclusion? Did he reject the null hypothesis, or he failed to reject the null hypothesis? So if he concludes this way, it means that what? He rejected the null hypothesis. Because the null hypothesis will say that what? The new scanner is not different from the what? The old scanner, or is that okay? So since he concluded that the new scanner is significantly better than the current scanner, it means that what? He rejected the null hypothesis. Do we all understand that? Okay. So if he rejected the null hypothesis, what does that mean? It means that what? The p-value was less than, you see, he told us the alpha level is what, 0.05. It means the p-value is less than 0.05. I don't know what the p-value is, but I know that it's definitely less than 0.05 because of his conclusions here. Is that okay? Now, the question is that would he have made the same decision at this level and at this level? If he rejected at 0.05, he's definitely going to reject at 0.1. Does that make sense? If he rejected at 0.05, he's definitely going to reject at 0.1 because let's say that we know the p-value to be less than 0.05. So you know that what p-value is less than 0.05 because what he rejected. This p-value, I don't know. Is that okay? So in my mind, let me just put 0.04 here. Okay? Or you could put 0.03, any number. Is that okay? So he rejected. We are comparing to this. If this is now 0.1, it's still going to what? Reject. Is that okay? Remember, we are doing what? P-value less than what? Alpha. So 0.05 or less than, now this is what? 0.1. It's still going to what? Reject. Is that okay? But if it's 0.01, you cannot tell because this is also less than that. So it depends on the p-value. Does that make sense? So that is how to answer that. So you can see from here that his decision would have been the same for this. He's still going to reject, but maybe different because this one is even less than what, 0.05. Is that okay? So it depends on that p-value. So that is going to be for C. And then you can check your answer and then that works. I think I would end here and then on Wednesday, we will do this example and then finish chapter 19. So I'll see you on Wednesday. Yeah.